Hey guys, welcome back in. Mr. Marone here with your last flip video for section 5, for chapter 5 I should say. And we're going to look at inequalities in two triangles. And this brings up one main concept called the hinge theorem. So you guys all know what hinges are. They attach doors to walls, and it allows us to move things fairly easy. It's a simple machine. They're great things. So we can use them and use the concept of a hinge to evaluate triangles. And if we look closely at this example here, we talk about this unicycle. So it says, as a rider pedals a unicycle, how does angle A, the angle between the pedals and the wheel, how do they change as we ride on? And if you notice, this side where our pedal is, as he starts to pedal, the side length of B increases. In other words, the size of that triangle increases. When the pedal's up near the top, the triangle looks like this. As the pedal moves, the seat length doesn't change and the pedal length doesn't change, but the third side of that triangle changes. Right? If you're riding a bike, your seat isn't going up or down and the pedals aren't getting longer or shorter, but that distance between the seat and the pedal does change based on where the pedal is. If you also think about it with a door frame, if I open a door just a little bit, we're looking straight down on the door. If I open a door just a little bit, it looks like this. The door size doesn't change, and the frame doesn't change, but this opening is going to change, where if I swing the door all the way open, once again, the door hasn't changed, and the hinge or the frame hasn't changed, but this opening here has gotten much larger. And so that creates this idea of the hinge theorem. So this tells me if YWX, if this angle is greater than angle CAB, in other words, this angle is larger than this angle, then what that tells me is that the side opposite that is going to be larger than the side opposite that, or that XY is going to be longer than CB. So we're taking the same idea of sides and angles across from them having a relationship, and now we're applying it to two triangles. And it works both ways. If I'm given angles or given sides, we can go interchangeably. So we've got one example of this, and then that's it. It's a quick hitter kind of a section. There's not a ton to this. So here, they want to know what are the possible values of x, this x in here. So they've given us three triangles, and in all of them, they've given us two sets of congruent sides. So that tells me this hinge theorem is going to work. And so what we'll have to do is create a relationship here. So if we look closely, if we ranked these from small all the way up to largest, based on their angle sizes, we can say, and we can use their sides, I should say. So if I'm looking across from these angles, it appears that EFG is the smallest triangle, followed by CDE, and finally we have ABC. So across from each of these, looking at their side lengths, that tells me that this side here, this 36-degree angle, whatever x is going to equal, it's going to be larger than my 36-degree angle. At the same time, we know since 18 is less than 21, that my angle here that we're looking for has got to be less than 60. So we end up setting up this double inequality, which I know you've worked with in the past. If you don't remember how to solve this, I'm going to solve it algebraically as I would any other problem. I'm going to add 4 to both sides, but in this case, I'm going to add 4 to all three sides. So I've got 40 is less than 2x is less than 60. And then I'm going to divide everything by 2. So I have that 20 is less than 2x, is less than x, which is less than 30. So in other words, our possible values for x are anything that's greater than 20 or less than 30. So it's kind of a crazy concept, but it allows us to use inequalities to find possible values. So the key for all of this is you're going to see possible values, meaning more than one possible answer. So just keep that in mind as you go through these. If you have any questions, bring them in tomorrow. We're going to look at this and kind of wrap this section up and hopefully clarify any questions you may have. Have a great day, guys. Bye-bye.